All right, the Subcommittee on Research and Technology will come to order. Good afternoon, or good morning. Welcome to today's hearing entitled Methamphetamine Addiction Using Science to Explore Solutions. In front of you are packets containing the written testimony, biographies, and truth and testimony disclosures for today's witnesses. I recognize myself for 5 minutes now for an opening statement. I'd like to welcome everyone to today's Research and Technology Subcommittee hearing entitled Methamphetamine Addiction Using Science to Explore Solutions. The problem of methamphetamine or meth abuse is a serious problem facing our country today. The main compound from which meth derives is pseudoephedrine, known as PSE, which is also a common drug used to treat nasal and sinus congestion. Unfortunately, criminal dealers have discovered new, easier ways to make more potent forms of meth that require the use of chemicals such as PSE. As our witnesses will testify today, meth poses significant public safety and health risks, in addition to financial burdens to local communities where these toxic and dangerous labs are found. According to a 2013 Government Accountability Office report titled State Approaches Taken to Control Access to Key Methamphetamine Ingredient Show Varied Impact on Domestic Drug Labs, the number of meth lab incidents declined significantly after 2004 when state and federal regulations on PSE product sales were implemented. Since 2007, however, these numbers have significantly increased, reflecting the emergence of smaller-scale production facilities by a new method called smurfing, where individuals purchase the legal limits of PSE at multiple stores that are then combined for meth drug production. They also buy it from multiple other people, including, in some reports, college students who are gaining extra money by selling these products at a much higher cost than they can buy them for. But more than figures and statistics, meth addiction is a problem that personally hits home for many Americans. As a medical doctor, I personally know the devastation that addiction can cause, and even after meth addicts kick the habit, some research shows these addicts experience permanent damage, similar to what LSD may have caused back in the 60s and 70s. From January to July of this year, over 65 meth labs have been dismantled in the biggest county in my district, Vandenberg County, making it the #1 county for meth labs in the state of Indiana. This is extremely close to my home next door in Warwick County, where we have had 2 meth lab explosions within a 2-mile radius of my house. In November 2011, a meth lab exploded down the street from my house in a middle-class neighborhood, burning down that house and causing over $25,000 damage to surrounding middle-class homes. So this is not a problem that is only isolated to certain areas of our communities. Despite the grim realities of meth addiction, science can provide valuable insights to this problem. Basic science agencies like the National Institutes of Health have spent over $68 million in fiscal year 2013 to understand the neurological basis of meth addiction. The National Science Foundation also supports fundamental, non-medical basic science research, in particular behavioral research behind the psychology of addiction. Our witnesses today reflect the wide spectrum of work and research regarding the various facets of the meth problem. Witnesses will introduce the extent of the meth problem and will discuss a wide range of topics on how science can help us understand the prevention and treatment of meth, as well as how technology can be used to stop unauthorized purchases of PSE. I would like to thank all of our witnesses for being here today, taking the time to offer their perspectives on this critical topic for our communities. I'd also thank Ranking Member Lipinski and everyone else for participating in today's hearing. At this point, I will now recognize the Ranking Member of the Subcommittee, the gentleman from Illinois, Mr. Lipinski, for his opening statement.
Thank you. I want to thank you, Mr. Chairman, for holding this hearing, and thank our witnesses for being here this morning. As a representative from the state of Illinois, I'm very interested in this topic because my state experienced some of the same meth abuse problems as Chairman Bouchon's district and state. Geographically, Illinois sits right in the center of the top 5 states in the country for a number of clandestine meth lab incidents reported in 2012. With 801, it had the 5th highest number of lab incidents. My colleagues in districts affected by heavy meth abuse, as well as my colleagues in districts affected by other illegal drugs, understand the heavy burden placed not only on families, but also the local economy, hospitals, law enforcement, and the court system. Unfortunately, if the sequester continues, Illinois will lose about $3.5 million in grants to help prevent and treat substance abuse, resulting in around 3,900 fewer admissions to substance abuse programs. Congress and individual states have developed laws aimed at making the precursor chemicals for methamphetamine harder to purchase, as the chairman stated, but there's still more work to be done. In order to do our jobs and craft effective policy to combat meth addiction, we need to know more about the science behind addiction and effective prevention and treatment programs. Much of the research we will hear about this morning is funded by the National Institute on Drug Abuse at the National Institutes of Health, which unfortunately is not in our committee's jurisdiction. I hope today we also have an opportunity to explore the types of foundational social and behavioral research, as well as the neuroscience research, that underlines much of the more application-driven research that is the purview of several of our witnesses today. As Dr. Gene Robinson testified at the Brain Initiative hearing in July, it is necessary to understand how healthy brains work from both a functional and behavioral perspective in order to cure the many devastating brain disorders that afflict our society. This is the type of science championed by NSF. Because of the important work already supported by both NSF and NIDA, our society is starting to accept addiction as a disease of the brain influenced by environmental factors. Many people addicted to drugs trace their problems back to their school years and acting out teenage curiosity. Thus, to meaningfully change this trend, our conversation must also include teen behavior and drug use, and how we might use the education system and public education campaigns as vehicles for prevention. Unless we apply what we know about teenagers' brain and behavior to the design of such education efforts and change course as we learn more, we may be setting ourselves up to fail. I look forward to Dr. Napier's testimony on her work studying the adolescent brain and supporting school-based curricula to help kids build good decision-making skills. These are the very skills they need to keep themselves out of a penal system where they are often introduced to a network of drug dealers within their communities, making the likelihood of relapse after release from jail very high. Social networks and markets for meth are also important topics of research that can inform the development of more effective prevention policies. For example, we know that meth abuse often circulates within families among close acquaintances. Additionally, as I understand it, whereas meth labs used to be typically in a room or basement of a home, a 2-liter shake and bake bottle can now be quickly improvised in the backseat of a car or behind the dumpster in a schoolyard. We also know that meth is more successful in penetrating some markets than others. Identifying and understanding the factors behind the meth market and how meth abuse spreads in social networks is a challenge that requires collaboration among social scientists and law enforcement officials. Finally, evidence-based policymaking is essential for effective treatment. If meth addicts are only fixated on their next high, as research has shown, then the standard 12-step program will not be an effective treatment tool for them. Treatment programs for meth addiction have evolved based on our increased understanding of what works and what doesn't, but more progress is still needed. As a social scientist myself, I find all of these to be interesting, compelling research challenges. Before I close, I'd like to mention that a bipartisan law was passed through our committee in 2007 that addressed meth, specifically with a focus on a lack of national standards for remediation of meth labs. For every pound of meth produced, 5 to 6 pounds of toxic byproducts remain in walls and carpets, as well as ventilation and wastewater systems. Perhaps it's worth the subcommittee, through its jurisdiction over NIST, reviewing where we now stand with respect to remediation standards. I think this is an area in which we can work again on a bipartisan basis for the health of our first responders who investigate meth labs and citizens in those communities. Again, I look forward to hearing testimony from witnesses and hope the testimony can get us thinking about how research can help us better tackle the increasing meth addiction problem plaguing our communities. I yield back the balance of my time.
Thank you, Mr. Lipinski. And I now recognize the chairman of the full committee, Mr. Smith, for his opening statement.
Thank you, Mr. Chairman. 6 weeks ago, this subcommittee held a hearing on the frontiers of human brain research. During that hearing, our witnesses discussed many different neurological disorders, including Alzheimer's disease, autism, epilepsy, Parkinson's disease, and traumatic brain injury. However, witnesses did not have the opportunity to discuss another important disorder, namely addiction, which affects millions of Americans and their families. Our witnesses this morning will testify about how meth addiction leads to severe medical and social consequences and why this drug is particularly destructive to the addict. The meth problem is an example of a clear societal need where science can yield potential solutions that will benefit the American public. Progress on this problem, like many other complex medical issues, will require an interdisciplinary approach that will inform the scientific basis of meth addiction and treatment. The National Science Foundation will play an integral role in achieving a more complete understanding of this problem. Hypothesis-based, data-driven social science research can be used to understand the behavioral science behind addiction. Scientists should work with health officials to develop predictive models and algorithms that could aid law enforcement. Applied mathematicians should work with neuroscientists to develop the mathematical tools necessary to build a quantitative model that could help explain the neurological factors behind addiction. These are just a couple of examples where NSF money can be effectively spent to help solve an important societal problem. I look forward to the witnesses' testimony and to questions, and I would especially like to thank a constituent of mine, Dr. Jane Maxwell from the University of Texas, for being here this morning and for her participation. Mr. Chairman, finally, I explained to the witnesses a few minutes ago that unfortunately I have another committee that is holding a classified briefing that I have to attend that began 20 minutes ago, so I'm going to have to excuse myself. I do want to reassure the witnesses that I've seen their testimony and we appreciate again their contributions. Thank you, Mr. Chairman. Yield back.
Thank you, Chairman Smith. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. This time I'll introduce our witnesses. Our first witness today is First Sergeant Nikki Crawford from the Indiana State Police. She is also the commander of the Methamphetamine Suppression Section. Sergeant Crawford received her bachelor's degree from Indiana University in secondary education. And since 1993, she's been with the Indiana State Police and has served in various capacities in a variety of locations around the state. Her responsibilities with the Methamphetamine Suppression Section include overseeing all operations of the 125-member Indiana State Police clandestine lab team and supervising 18 full-time personnel assigned to the Methamphetamine Suppression Section. Our second witness is Professor Edith London from UCLA. Professor London is an internationally recognized expert in the study of drug addiction. At UCLA, she is the Thomas P. and Catherine K. Pike Chair of Addiction Studies and is a professor in the departments of Psychiatry and Biobehavioral Sciences. In addition to the Department of Molecular and Medical Pharmacology. She received her doctoral degree in pharmacology and toxicology from the University of Maryland. Before joining UCLA faculty in 2001, she worked at the National Institutes of Health for 2 decades, conducting independent research at the National Institute on Drug Abuse. In 2008, she received the Marion Fishman Award from the College on Problems of Drug Dependence. Our third witness today is Professor Jane Maxwell, who is a senior research scientist in the Social Work School at the University of Texas, Austin. Her research specialties include trends and patterns of substance abuse, both nationally and internationally. She is a principal investigator on a grant from the National Institutes of Drug Abuse to study patterns of methamphetamine use in the Central Texas area. She has been a Fulbright senior specialist and a member of the National Institute on Drug Abuse's Community Epidemiology Work Group for 25 years. Our fourth and final witness is Professor T. Celeste Napier, who is the director of the Center for Compulsive Behavior and Addiction and a professor in the departments of Pharmacology and Psychiatry at Rush University Medical Center in Chicago. Dr. Napier has over 30 years of research related to brain and behavioral effects of abuse substances and impulse control disorders that have been supported by grants from the National Institutes of Health and other private research foundations. She is the author of over 200 scientific publications, special issues, and books. Thanks again to our witnesses for being here this afternoon. As our witnesses should know, spoken testimony is limited to 5 minutes, after which the members of the committee will each have 5 minutes to ask questions. I now recognize First Sergeant Crawford for 5 minutes to present her testimony. Welcome.
Chairman Bouchon, Ranking Member Lipinski, and distinguished subcommittee members, thank you for allowing the Indiana State Police to be here to present to you on our meth lab epidemic. As you can see in Table 1 and Appendix A of the written testimony submitted, Indiana has seen the problem of local manufacture of meth rise over the past 2 decades, and the problem exists in every corner of our state. We have seen a variety of cook processes over the years, but the most significant change came around 2006 when we began to see the one pot or the shake and bake labs, where the entire meth cook is completed in a plastic bottle, glass jar, or other homemade reaction vessel. Because the one pot labs are used with non-compatible chemicals, more injuries to both meth cooks as well as law enforcement officers are occurring. The corresponding data can be found in Table 2. One-pot labs are a much quicker, easier, and smaller way to manufacture meth. Everyone asks the question, why are meth labs so pervasive? What is the difference between meth and other drugs? For us, from a law enforcement perspective, the difference that we see is that the vast majority of the meth labs in Indiana are not money-driven operations. They're addiction-based labs fueled by the need for a drug whose chemical precursor, pseudoephedrine, and the other chemical reagents used are readily available in local stores. Drug addicts are in a position where they can completely control their own destiny in terms of easy access to the chemicals and the ability to manufacture their drug of choice. On January 16th of 2006, the Indiana State Police launched the Methamphetamine Suppression Section, which consisted of personnel assigned full-time to investigate meth crimes. The State Police personnel historically and currently respond to 97% of all labs seized in the state. At about the same time, we launched the Meth Watch program. It focused on deterring meth cooks by educating retailers and citizens and putting Smurfs on notice that we were watching purchases of certain chemicals. Smurfs, by definition, are those people who purchase pseudoephedrine products and other reagent chemicals to be diverted to the meth cooks. Meth Watch kits consist of posters, signage, employee training materials, and brochures. The program was expanded to include stickers to warn thieves and tamper tags to track the thefts from anhydrous ammonia tanks. The success of the program was in the building of investigative relationships between law enforcement and retailers and citizens who sell and also use the products. However, the disappointment of the program was that signs did little to deter the Smurfs and meth cooks. A sampling of the Indiana Meth Watch items have been provided to the committee for your review. Following the launch of the Meth Watch, the State Police also launched the Indiana Meth Investigation System, also known as IMIS. The front end of IMIS is an informational website, and the link is in your packet. The backside of IMIS was a secure meth investigation database for law enforcement to use. Although the State Police knew IMIS would not be a preventive measure, it did allow more efficient investigations and lab reporting both on the state and federal level. In 2011, Indiana, as well as many other states across the country, were mandated by law to use the National Precursor Log Exchange, or NPLEX. NPLEX is a national electronic tracking system of pseudoephedrine products. NPLEX was lobbied for under the pretext that it would prevent the illegal purchase of pseudoephedrine products by blocking sales that exceeded the legal limits, and therefore it would prevent meth labs. Unfortunately, this has not been the case. The meth cooks' response has been to double and triple their Smurf groups to accommodate the law changes that have been made. As stated earlier, the GAO did a study where they studied the results of tracking states versus controlled substance states. And in the country, Mississippi and Oregon are 2 states that returned pseudoephedrine to a prescription-only status. There are a few pseudoephedrine products that are being marketed as meth-resistant. The technology focuses on the prevention of the extraction of pseudoephedrine from the tablet and impeding the conversion of pseudoephedrine to meth directly from the tablet. It's exciting to see companies working on this technology and in that direction, but of all the samples provided to DEA, their chemists have been able, unfortunately, to defeat the technology to some extent. Ladies and gentlemen of the committee, the word for the day is Smurf. Most meth cooks and Smurfs are also involved in other property crimes such as burglary and theft. However, the newest and most pervasive crime growth has been Smurfing itself. With the establishment of the NPLEX system and mandated block sales, the black market for pseudoephedrine products has significantly expanded. Meth cooks are soliciting the services of family, friends, coworkers, college students, homeless people, and most commonly, other meth addicts to purchase their pseudoephedrine products. Bottom line, PSE products have become currency to meth cooks. The meth cooks pay between $20 and $100 for every box of pseudoephedrine, or they trade a box for a half a gram of meth, which has a street value of $50. There is rampant child neglect, endangerment, physical, and sexual abuse among the children being raised in these meth lab homes. Table 6 illustrates the growing number of children that are being identified in homes and locations where we have seized meth labs. As the parents' addiction grows, the lack of supervision of their children also grows. The meth lab crisis is not an easy problem to solve, but this particular drug problem causes a much deeper damage to people and communities than other drug crimes. Those of us in law enforcement who have chosen this route in our career know that we will deal with drug-endangered and abused children, theft, burglary, and violence. Communities are dealing with contaminated homes that lead to innocent illness of parties, abandoned properties reducing property values, and fewer employable citizens to contribute to the economy. As federal, state, and local leaders determine if additional steps are necessary to combat this problem, rest assured that we in law enforcement will remain on the front lines enforcing the applicable laws and fighting for the safety of our children and communities.
Thank you very much. I now recognize Dr. London for her testimony.
Chairman Bouchon, Ranking Member Lipinski, and members of the subcommittee, thank you for the opportunity to testify on the problem of methamphetamine addiction. My name is Edith London, and I direct the Laboratory of Molecular Neuroimaging of the David Geffen School of Medicine at UCLA. I'd like to note at the outset that strong support from Congress to the National Institutes of Health and its grantees over the past 2 decades has enabled research that is driving the development of new treatments for this problem, which needs your continued support. Among illicit substances, methamphetamine and amphetamines in general are second only to marijuana in prevalence of use worldwide. Methamphetamine abuse is associated with crime, premature mortality, lost productivity, and a host of medical problems. Illegal methamphetamine use in our country is now reduced from the levels in 2006, but the problem is still very severe where there are established cores of users and supply connections set up with the Mexican cartels. In California, for example, admissions to treatment for methamphetamine use disorders in recent years exceeded those for all other substances, including alcohol. Like cocaine, methamphetamine augments the action of dopamine, but it is a more effective stimulant, has a longer duration of action, and is more potent, addictive, and toxic than cocaine. It also is relatively easy to manufacture and has, as you just heard, a low street cost. Methamphetamine users stay under the influence for extended periods with sleep deprivation and poor health maintenance, leading to medical and psychiatric problems such as prolonged psychosis and suicide attempts. Methamphetamine use also is highly associated with HIV infection in gay men. Brain imaging techniques such as magnetic resonance imaging and positron emission tomography, MRI and PET, have helped clarify the effects of methamphetamine use on brain structure, chemistry, and function. This slide shows the difference maps of the lateral surface of the brain obtained with high-resolution MRI in a group of methamphetamine users and healthy controls. Red indicates a gray matter deficit in the methamphetamine group, especially in the prefrontal cortex on the right lateral surface, in a region important for inhibitory control. Deficits are also seen in medial aspects of the brain, and volume loss in the hippocampus is related to memory deficits. Unexpectedly, white matter shows hypertrophy. The findings suggest a pattern of deterioration that promotes cognitive impairment. The white matter hypertrophy may reflect reactive gliosis secondary to neuronal damage. These abnormalities accompany deficits in the brain's dopamine system, which functions in reward processing, motivation, self-control, and decision-making. PET scans have revealed low levels of dopamine receptors and dopamine transporters and hypofunction of dopamine neurons. Notably, markers for dopamine system integrity predict the outcome of behavioral treatments for methamphetamine use disorders. Functional MRI, which measures brain activity during cognitive processing, has shown that methamphetamine users recruit less neural activity in the prefrontal cortex than healthy controls while learning, paying attention, and being engaged in emotion processing. Functional MRI also can help evaluate the effects of potential treatments. These fMRI brain activation maps show the response to modafinil in cortical regions while methamphetamine users are performing a task that requires inhibitory control. The activation corresponds to improvements in learning, and modafinil is an agent that improves dopaminergic activity and has cognitive benefits. At this time, behavioral treatments are the most effective ones for methamphetamine dependence, but they don't help everyone. Efforts to identify a broadly effective medication for methamphetamine dependence have not been successful, but there are some promising leads, such as bupropion, which reduces use in a subgroup of patients. Studies from animal models and PET scans of humans have also identified other potential medications, buspirone and microglial activation inhibitors such as abutolast. This work has required collaboration of physicists, mathematicians who developed and improved the instrumentation and algorithms for data acquisition and analysis, as well as psychologists and clinicians. The field would be advanced with the development of new and more sensitive probes, but we need multidisciplinary teams. Such collaboration, for example, has proven that deep brain stimulation can be an effective treatment for depression. This advance required the confluence of several fields, including bioengineering, electrical engineering, material science, neurosurgery, MRI physics, psychology, and neuroscience. Optimizing therapeutics for methamphetamine addiction requires this type of multidisciplinary effort.
Thank you very much. Dr. Maxwell.
Thank you. My thanks to you and to the Vice Chair for inviting me, and I hope maybe I can shed some light on looking at this problem from an epidemiological standpoint or historically. We know that until 1970, we really didn't have a methamphetamine problem because amphetamine was available over the counter. Amphetamine was scheduled in 1970, and that's when we first began to see problems with methamphetamine. They were using the P2P or the phenylpropanone precursor that we're now seeing used in Mexico. And for the first 10 years, it was the bikers, and remember the crankcase meth, where they were carrying it in the crankcases producing the meth. In 1980, phenylpropanone was forbidden in the U.S., and that's when they started using pseudoephedrine. And this slide is very busy, but there's an easy message in it. If you look at the red lines, the vertical lines, that's every time either the U.S. or Canada had passed a precursor. And you can see that with that first precursor, the purity of methamphetamine drops, then it goes back up again. Another precursor ban, it drops, it goes back up again. So this is a drug that's very cyclical. We do one thing to it and think maybe we're making progress, and then it rebounds. This slide shows what the market looked like right after the law was passed limiting the ability to buy pseudoephedrine. The far left is the price and purity right after the law goes into effect. Then you see the price going skyrocketing and then dropping off. You see the purity, the blue line, dropping and then going up. And the intersection of interest is the one with the second green arrow. This is the middle of 2008. This is when the Mexicans first really started distributing the P2P meth in the U.S. And since then, the price has dropped dramatically, and we're now up to about 94% purity of the meth that's being tested by DEA. Two other data sets that are of use, the blue line is showing the proportion of all the methamphetamine that's tested that is now made from the P2P process. So it's about 93%. About another 2 to 3% is made from the pseudoephedrine. Now, one of the things that is not shown in this is a DEA only tests where the seizure is more than 6 grams. So a lot of the small amounts of meth that are made in the shake and bakes would not be tested. But basically, the market really, in terms of the massive quantities, is now the P2P. The red is the drop-off in the last 2 years in the number of precursor clandestine labs as reported to DEA. Not sure what's going on, but we may be seeing the Mexican meth beginning to move in other areas and perhaps overtaking some of these small labs. This is the Texas data, and I put it up there because it's 15 years of data. And the red line is 2006. So you can see after we get the precursor, whether it's deaths or poison center exposures or treatment admissions or tox lab incidents, they all drop after 2006 in Texas. They're now going upwards again. So another cycle. Oh, I'm back. And besides using the quantitative data, I always get out on the street and ask people who are working out on the street what's going on. They're telling me now they're seeing more psychosis now than they saw 6 months ago among the users. The meth is very, very pure. The high is very, very intense. More use of needles. Syphilis is up. DEA is reporting more and more seizures in the Dallas area of 100 pounds or more, and they're reporting availability of meth is higher than it's ever been. So more bad news. This is a map of the tox lab data from DEA, and basically it's showing, yes, meth's a problem in the West. But there was something else that really bothered me, and I went and looked at the data. This is 2010. And there are 7 states in the Northeast that are white. They don't show, so that they reported no meth in 2010. When I ran the data last night, we're down to only 3 states that didn't report meth in 2013. And this is a report. I'm a member of NIDA's Community Epidemiology Work Group. The members reporting no diminution in meth. It's not decreasing, it's increasing, or it's staying stable. You asked for information on data and methodologies, and I put this in here for your assistance to you. So with that, I thank you.
Thank you very much. Dr. Napier.
Chairman Bouchon, Ranking Member Lipinski, and distinguished members of the subcommittee, thank you so much for the opportunity to testify on how science can provide solutions to the problems associated with methamphetamine abuse. Methamphetamine is an insidious drug, and while the user initially experiences an incredible sense of euphoria, the brain's natural brake system is overridden, and the consequences of this overload can be devastating. Methamphetamine can cause brain abnormalities that occur even years after the addicted individual stops using the drug. And understanding these persistent abnormalities is an important topic for modern neuroscience. Highlights of my own research can underscore this point. We studied the effects of methamphetamine in laboratory rats. These rats readily learn to press a lever in order to receive an infusion of methamphetamine into their bloodstream. And if we let rats self-administer methamphetamine for 2 weeks and then leave them alone for different periods of time, we find that by 3 weeks of abstinence, the rats' brains have degenerated and they look similar to the brain of a human that has Parkinson's disease. Such findings provide neurobiological explanations to recent reports that human methamphetamine addicts have a 75% greater risk to develop Parkinson's disease than do controls. and increasing prevalence for Parkinson's disease has enormous health and medical cost ramifications, and we are now working to identify viable biomarkers of Parkinson's disease-like pathology in methamphetamine abusers, with the hope that pre-symptomatic detection will allow early therapeutic interventions to avoid this outcome. As suggested by these studies, effective treatments for methamphetamine abuse may be those that work after the drug taking has stopped. Indeed, relapse by the withdrawn addict is as high as 70%, and thus halting relapse is a high priority for medication development. Basic research has identified treatments that reduce relapse-like behavior in laboratory rats, as Dr. London had indicated. We are using treatment protocols that are already used in humans to treat other diseases. Such a repurposing provides a relatively rapid and cost-effective process to bring treatment to market. To attract the interest of pharmaceutical industry to the patent opportunities of this endeavor, we're working with an innovative foundation named Cures Within Reach. This foundation is stewarding fundraising for repurposed treatments that we think should reduce cocaine and methamphetamine use. We feel that teaching old drugs new tricks is a win-win model that should be explored to its greatest extent by academic biomedical researchers, government agencies, foundations, and pharmaceutical companies alike. An example of the urgent need to develop effective treatments for addiction is in our nation's jails and prisons, where approximately 80% of the incarcerated have substance abuse problems. As drug courts mandate treatment, we are working with the continuing legal education programs to integrate the neuroscience of addiction in order to help inform sentencing decisions. I think that such knowledge base is especially important for methamphetamine cases for which coerced treatment is often the only way that the addict will access help. Particularly vulnerable to the ravages of methamphetamine are the nation's youth, as Mr. Lipinski mentioned. Each day in the United States, more than 4,500 children try an illicit drug for the first time. As these striking data suggest, the traditional approach to drug education is largely ineffective. New strategies are critically needed, and I believe there's a role for neuroscience in this endeavor. Recent initiatives by the Robert Crown Center for Health Education, a not-for-profit organization based in a suburb of Chicago, in conjunction with our Addiction Center at Rush University, is providing what I believe to be an excellent template for this goal. The Robert Crown Center is developing a completely new educational framework that integrates knowledge-building strategies for middle school, high school students, school personnel, and parents. Our center provides access to cutting-edge brain research. Thus, the prevention program includes both the neuroscience-based knowledge of how abused drugs act on the adolescent brain, as well as the social economic learning required to reduce drug abuse among our youth. Understanding how the brain goes awry during methamphetamine abuse is a formidable challenge. The exciting advances that we've made towards this challenge attest to the ingenuity and determination of the addiction neuroscientists. But to continue this trajectory, we must carefully consider where to direct our resources. Successful templates should be supported, and promising new paradigms should be considered. Education programs need to be promoted to translate the wealth of empirically derived neuroscience to our public. However, with concerted teamwork from all sectors of our society, I'm confident that we can meet the challenge of controlling the abuse of methamphetamine and reducing the suffering of those who struggle with addiction. Thank you.
Thank you all for your testimony. I remind the members in the committee rules limit questioning to 5 minutes, and the chair at this point will open the round of questions. I recognize myself for 5 minutes. Dr. Maxwell, epidemiologically, I guess, that's what you do, I guess. Urban versus rural communities. Is there a difference in methamphetamine? Because I'm in a relatively rural area of Indiana versus Chicago, for example.
The difference is that treatment resources aren't available in the rural areas. I don't see any difference in the patterns of urban versus rural, but serious need for treatment facilities in the rural areas.
Sargent Crawford in Indiana, do you notice a difference?
We saw a big difference back in the late 1990s and the early 2000s when meth labs really started to grow. The vast majority of them were in rural areas. But now with the one pot or the shake and bake labs coming in, we're getting more and more labs in urban areas. I think within Indiana, Allen County, and even Vanderburgh County, while it's got some rural areas, it's the second or third largest city. So if you look at those two counties and the growth that they've seen, that kind of shows you that with the one pot labs, it's much easier to cook in an urban area.
Yeah, because you were commenting on how, it wasn't necessarily economically driven, it was addiction driven. And Dr. Napier, maybe you can comment on this. I've heard that, in certain respects, as methamphetamine tries to overtake cocaine, for example, or other drugs they're being sold by certain groups of individuals in urban areas, that in areas that there's a strong dealer in cocaine and that's where the money is, that methamphetamine has a hard time breaking into that. Is that true or not true? Is that a perception? Dr. Maxwell and then Dr. Napier?
No, cocaine is down. There's a shortage of cocaine because a lot of it's going to Europe now. And I'm hearing more and more of people who are shifting to methamphetamine because cocaine, the cocaine we're getting is not very pure. It's not worth, quote, paying for. No, they're going to methamphetamine now. Meth has far outpaced in most of the states cocaine in terms of prevalence.
Dr. Napier, in Chicago?
My understanding of what's happening in Chicago is two things. One is it's still a very rural problem. Southern Illinois, as Mr. Lipinski knows, has some clandestine labs that are really supplying the problem there. In Chicago, there are certain subpopulations of people that abuse methamphetamine more than others. For example, men who have sex with men. Our gay men community are one of the higher users of methamphetamine in the city of Chicago. In the south side of Chicago and the west side of Chicago, cocaine is still the preferred drug. But I predict that we will be seeing more methamphetamine infiltrating the city as it becomes more readily available.
Dr. London, in the area of research, and I know you do research on the effects of it, but I've discussed with FDA about trying to find ways to make pseudoephedrine not usable to produce meth. Are you aware of universities and other people, and industry, are doing any of that type of work?
I'm not aware of that.
Yeah, and I think Sargent Crawford, you mentioned some of that, the tamper resistance and things like that, and it's a very interesting subject because pseudoephedrine in and of itself, it's not going to be a Schedule I drug, for example, because it's just not a Schedule I drug. So attacking it from the FDA standpoint by trying to schedule one drug based on the fact that you produce another drug is not something that can be done at this point because of legal challenges and other things. So I'm interested in the science of not only finding ways to treat people that are on it, but try to make it more preventable, to make it in rural areas like in Indiana. I recognize the fact that a lot of this is going to come from Mexico, and that's a different problem to attack. So we really have two separate problems, I think, here as it relates to that. And with that, I'll yield to Mr. Lipinski.
Thank you. I want to thank all the witnesses for their testimonies. It's fascinating to hear this, and very troubling in many ways. I want to start out with Sargent Crawford. As I mentioned in my opening statement, the Methamphetamine Remediation Research Act passed through this committee in 2007. I was a co-sponsor. I believe it was spearheaded by the then chairman of the committee, Bart Gordon, from Tennessee. In that bill, which became law, it established a research program on residue from methamphetamine production and developed voluntary guidelines for preliminary site assessment and remediation of meth labs. At that time, most meth was that was cooked in drug houses, as you spoke about in others. The new shake and bake method of cooking, seizures aren't restricted to collecting items in drug houses. So, if this committee were to revisit the law that I mentioned, we'd need to take this into consideration. Is there anything you could say about the new kinds of immediate or long-term risks, if any, that are faced by law enforcement officials in surrounding communities, given the prevalence of the new method?
I think the biggest issue that we're having is really in terms of the dangers associated with the one-pot labs. When we first started to see them, we didn't really understand. We understood the chemistry, but we didn't understand the long-term effects, and we didn't realize what an enormous amount of ammonia gas that the one-pot labs actually create. And so when you look at injuries, especially to law enforcement, that's our issue that we're dealing with right now, is the exposure to the ammonia gas that comes off of the one-pots, because it creates its own ammonia gas within the reaction vessel itself. So in terms of the contamination that we are dealing with these labs, whether it's a one-pot lab or other, is typically going to be your ammonia gas. But the bigger issue is in the last step of the process, when they salt out or they solidify the meth and they introduce hydrochloric acid gas to the reaction vessel, those molecules bond with one another, and because it is a gas, it escapes into the air. And that's typically the types of exposures that we're dealing with, both long-term exposures from facilities or homes or cars or whatever it is that have had cooks happen in them, especially long-term. Automobiles are a little bit less because you can roll the windows down. They're smaller. They're not going to hold in the contamination as much as others, as a house or a hotel room would.
Thank you. Dr. Napier, I just wanted to ask you, you had talked about these new programs for educational programs. Is there anything more that you would like to see us doing here in Washington that would help to help the research that would feed into these programs, or in the helping to disseminate the findings of research and get this out to people?
There's always room to grow and help needed. From my perspective, in working with these outstanding educators, one of the things that we really are trying to do is determine if outcomes, are we really making a difference with our new curriculum? So we have several schools that have served as beta test sites in the Chicago metropolitan area, and we're just now getting feedback from our first year of implementing this curriculum in different schools. What we need to be able to do is to customize this curriculum to the individual community schools and then determine if we're as effective in the different environments, because clearly the way we're going to reach children, for example, in rural areas is going to be quite different than what we're going to be needing to use in the suburban parts of Chicago. So this kind of epidemiology and this kind of validation of outcomes support takes money. We have to hire people to do this. We have to have researchers employed. And so this, again, is an area where grant support mechanisms could be very critical in driving a momentum to get this thing to the schools as quick as we can.
And is what about the funding for the research that's going on to learn more and to improve these educational programs? Is there I know there's always a need for, you could say, for more, but is there anything that's missing, anything that can be done differently?
Well, there are mechanisms for this kind of educational directives, if you will, through both the NIH and at NIDA, as well as NSF. And I think that what we need to do is to take those vehicles and optimize them. One idea that we might explore, actually, as you know, all of these programs have training grants. So we're putting young people in their PhD programs on training grants that are being supported by NIH. One of the things we might consider to do is that there would be a component required of these training grants to have these students volunteer. And this could be part and parcel to their training and part and parcel to the institutions getting the grant awarded. And I think that kind of infusion of these young these are young men and women who are going into the neurosciences, who are right out of college, and having them work in these different high schools and junior highs would be a huge infusion of great knowledge and an understanding that would be very useful in these kinds of programs. So that's something that might not cost so much money, that might be very effectual.
Great. Thank you.
Now recognize Mr. Schweikert for his questioning.
Thank you, Mr. Chairman. Professor London, and forgive me, some of my knowledge on this is a bit outdated, but walk me through methamphetamine and its attachment to the receptors, is it different than other opiates in both the dopamine receptors and other parts in the brain?
Methamphetamine interacts with the dopamine transporter. It's taken up into neurons that use dopamine as a neurotransmitter. It gets into the vesicle where dopamine is stored and reverses the activity of the transporter so that lots of dopamine is released into the synapse, and these very high concentrations that are released, much more than are released from the administration of cocaine, are toxic because dopamine itself in high concentrations will auto-oxidize.
Almost to that, wasn't there, and in fact, wasn't even happening at a couple of the big Southern California universities a couple of years ago, looking at abilities to almost block those receptors from absorption. Do you have any memory of what happened or where that research is?
Yes. At this point, with respect to interacting with the dopamine transporter, one of the best clues that we have for therapy is with bupropion, which has as part of its action the ability to enhance dopamine function by blocking the transporter. It's in a sense a type of agonist or mimic for the drugs of abuse, but without the abuse potential.
Okay, so if I remember my little friend who was trying to explain this to me, she actually sort of drew with crayons so I would understand it. So it's amazing how, 2 times in life you think you know everything when you're 14 and when you become a member of Congress. Is it an actual block on the receptor, or is it changing the, as you call it, the transporter?
Methamphetamine interacts with the presynaptic element of the neuron. So all of the transmission takes place at the gap in between neurons, which is called the synapse.
Yes.
And methamphetamine acts at the first neuron in the sequence, causing massive releases of dopamine. This massive release of dopamine really destroys the system over time, in that the dopamine receptors that are needed for dopamine to have its normal activity are downregulated. And in fact, the presynaptic element doesn't function very well in terms of releasing dopamine in response to natural rewards.
Okay, the impossible to answer question is where do you think we are in the research of being able to have a pharmaceutical sort of solution to at least either blocking those receptors, and would it only be meth specific, or would it be other types of opiates?
Well, meth is not an opiate; it's an amphetamine, so it's got a different chemical structure, and the opiates interact directly with other kinds of receptors. With respect to a treatment that will help all methamphetamine abusers globally, I think we're not in good shape. But we do have treatments that help subgroups of methamphetamine users. For example, bupropion is effective in reducing stimulant use by individuals who use methamphetamine on fewer than 18 days a month, but not in the heavy users. There's also a positive signal of bupropion being effective in men who have sex with men. There are clues from the recent pet literature and animal studies that there are other targets that haven't been used as therapeutic targets that might be useful.
Okay.
One of them is the D3 receptor, which seems to be upregulated in meth users, and blocking it in animals reduces methamphetamine self-administration.
All right, thank you. And I know we're very, very short. Dr. Maxwell, wonderful data you've put together. My quick question is, let's say we had great success in strangling the supply of methamphetamine. When you've been looking at data, particularly in the Texas environment, are there any other drugs that you see potentially in the upswing, either because of their price or their potency?
Okay, two different things. DEA is telling me that because of the pseudoephedrine, you can't get enough of it to cook a lot, and the problems with the P2P if Mexico bans it. We know people are out all over the world in Africa and South America looking for other chemicals that can be used to make meth. And in terms of other drugs going up, methamphetamine continues to go up. I'm worried about heroin among young users. And these synthetic drugs, we're just beginning to understand what's going on with them. And a lot of them are actually related to methamphetamine. We like uppers. We like trippy uppers that you can, it's kind of like combining LSD and...
See, I've always assumed that's why the dear Lord created coffee for me.
Exactly.
Mr. Chairman, I yield back. Thank you for your patience.
You're welcome. Dr. Barra.
Thank you, Mr. Chairman, and Ranking Member Lipinski, and thank the witnesses. I'm a physician by training, and I represent Sacramento County, where we've got, in Northern California area, where we've got a huge methamphetamine challenge. The Sacramento Bee reported that 40% of the men arrested in Sacramento County have meth in their system, just as we think we're making some progress, as Dr. Maxwell showed, those that are supplying, are staying one step ahead of us here. Increasingly, more of the meth that we're seeing does seem to be coming from Mexico and does seem to be being smuggled in as liquid as well. And then I think Sargent Crawford has talked about the ease of the shake and bake production. So if we focus on the back end, it looks like it's going to be a very difficult challenge for us to get a handle on. On top of that, when I look at our law enforcement, at one time most of our law enforcement agencies had narcotics units. Now a lot of our police departments have lost narcotic units. In Sacramento, the Sacramento PD shuttered their narcotics unit in 2011. So that also adds to the challenge here. We've seen the ability to provide treatment go down. In California, in 2006, we had 78,000 patients admitted to meth addiction programs. Less than 5 years later, it's less than 44,000. So, I'm not painting a rosy scenario here. This is a challenge. And then concomitant to that, I was chief medical officer for Sacramento County. The number of folks that have dual diagnosis, mental illness and substance abuse, the number of folks that, by not addressing the root cause issues, we end up, building more jails. We end up having to build these back-end solutions. The challenge that drug addiction, not just methamphetamine but cocaine, and now we're seeing a huge uptick in prescription drug abuse, and the impact that has on the family social structure, the impact it has on the foster care system, et cetera. So there's these huge sociologic challenges. I haven't asked the question yet because these are real issues. We've talked a lot about back-end solutions, but if we were to look at the root cause issues and try to shift towards prevention and some of the social science that it potentially leads to drug abuse and addiction, I guess I'd ask Dr. Maxwell, where would you like us to focus if we were to try to focus on front-end solutions and root cause solutions?
Thank you. We've tried a number of different approaches to prevent youngsters from using drugs. There have been some that have been proved to be quite effective. But it seems like we start doing something and then we drop it.
Right.
I really wish we'd go back to some of those prevention programs that have, through the follow-up test, been shown to be effective.
Because it's probably making a commitment over a generation, right? I mean,
Exactly.
So what would you say some of those programs are that you'd like to see?
They're up on the SAMHSA website, and I can give your staff the links to it, but some very, very, very good ones. So before we start over again, I think it's time to go back and look at which of those are the most effective and could be modified to handle these new drugs.
Dr. Napier.
And to continue that dialogue, there's a couple things. One is we have to understand that the curriculums are regulated by criteria that have to be met. And so for us to come in with a new curriculum adds a huge burden on our already burdened teaching system. So we have to be very sensitive to that. So what I think is a good approach is a more integrated approach, and it needs to be over the course of the student's experience in junior high and high school. It can't be you have a speaker come in and give a talk in the auditorium and leave. It needs to be integrated into health sciences, PE, social sciences, and be science-driven. And I think that's where we have a lot more that we can do to make this better, to where good decision-making is part and parcel to drug prevention. And we all know that the adolescent brain is a different brain than the adult brain, and the capacity to make decisions is not the same. And we all know that the frontal cortex is not developed in children until they're 21 or 23. And so we need to have empirically based curriculum that will reach the adolescent in terms of these decision-making processes based on their neurobiology.
What would you say the right age for intervention is if we were to, elementary school?
Elementary school.
Okay.
Absolutely. And also, I think it's important to think about in urban situations where students drop out of school, you want to reach those children before the dropout rate starts to escalate. So again, that means starting them sooner.
Okay. Yeah, I'm out of time, but I don't know if Sargent Crawford or Dr. London.
We're going to do another round of questioning if you have more questions, if you can stay.
Fabulous. Thank you.
Yeah. So we're going to do a second round for those who can stay. And for whatever it's worth, I mean, I have 4 kids, age 20 to age 9. And Dr. Napier, maybe you can comment on this, but even though us as parents think we're the ones that have the most influence over the direction that our children take, in actual fact, that their peer group has probably more overall effect on what they do every day than we do. And so I found it interesting when you were talking about having volunteer children or high school kids who, rather than having the county sheriff come out and talk about the Just Say No program and things like that, which also needs to be done, is working on designing programs that actually get people of the same age that are willing to interact at a peer group level to try to affect that. Do you think is this something that would be effective?
Well, I think there's a couple points here that you made that are really important to bring home. Number one is the influence of peers. Now, we all know, even in basic research, which is what I do, that people, places, and things influence the way an animal, in my case the rat, will make decisions about taking drugs. And the cues associated, or the things that are associated with the drug taking, has a huge influence on subsequent drug taking. Now, you superimpose that on the brain of an adolescent, which is wired to be more sensitive to these environments and to their friends. That's the way their brain is made. And then they have hormones. So all of these factors sort of escalate into this thing we call a teenager that greatly influences how they're making choices and who is going to inform them about the kind of choices they make. So that's why I do agree that getting younger people that may relate to the students in a more level that they can sort of gear into is something that we could exploit more. But I don't want it necessarily to be teenagers. My suggestion had to do, these would be graduate students and medical students. So they're in their mid-20s that would be able to come back to junior high and high schools. And they would have a science-based knowledge that then could be incorporated into whatever curriculum is being implemented by that particular school.
Yeah, I find that's just a fascinating subject because, like I said, I have 4 kids, and like cigarette smoking, for example, there's studies on why almost every teenager at some point tries cigarettes, but only a certain percentage of them actually become chronic smokers. The reason they originally tried is because of peer pressure, peer group stuff, even in contrast to the factual data that shows that cigarette smoking in the long run is bad for your health. That doesn't seem to influence, most people are not influenced by that when they try it, but why some people become chronic cigarette smokers and others don't is fascinating. And that, in meth, my understanding is you don't have a second chance a lot of times. I mean, once people start to get on meth with the changes Dr. London has described, you may have a higher percentage of chronic users of methamphetamine versus cigarettes, for example. And that's why peer group stuff, I think, may be important. Dr. London, once these changes happen, are these permanent? I mean, are these reversible?
There have been studies with positron emission tomography on both the metabolic pattern in the brain, glucose metabolism, and also some of the dopamine receptor markers and structural markers. And in fact, what we found is that decrease in the volume of the striatum, which is a part of the brain that's very important in reward and motor function, does recover to some extent. And there can be recovery in as early as a month of abstinence. With respect to some of the chemical markers, it takes a very, very long time to reach recovery, and at 2.5 years after cessation of chronic methamphetamine use, one area of the brain that's affected, the thalamus, shows complete recovery, where another area of the brain, the striatum, does not show complete recovery. So it's a very long, drawn-out process, and it can be very frustrating for the addict who's approaching a treatment episode, because what happens is that these people, as a result of these structural and biochemical changes that are very long-term, are very frustrated when they're in treatment, because the treatments are behavioral treatments where they have to exercise some kind of self-control in thought stopping, and they're really not very able. So I think educating the client, in addition to ultimately developing some medications that can help the cognitive therapy along, would be useful.
Yeah, it seems to me from what you just said is there's going to have to be a medication in addition to other therapy if we're going to fix this for people who are chronically addicted to methamphetamine. And so that's why ongoing research is so critical to try to solve this problem. We'll go to Ms. Lummis for our questions.
Thank you, Mr. Chairman. I sure appreciate the panel's attendance today, your knowledge, your information. As you have testified, there was a wave of addiction going from the West Coast to the East Coast. It swept across my state of Wyoming into the Midwest, leaving almost a lost generation where children of addicts are being raised by their grandparents. People in their 30s and early 40s are struggling with addiction. It was staggering, and it has affected every family, including my own. So the work you're doing is just critical to helping the recovery of this literal generation that was lost to this addiction that are now adults, young adults. Dr. London, I believe it was you that mentioned that the striatum does not recover after 2.5 years, whereas the thalamus does. Can you tell me what the striatum does?
Sure can. The striatum has multiple functions. On the most superficial level, we think about the striatum as being important in motor control. The striatum is one of the areas that receives a very, very rich innervation of dopamine neurons from the midbrain, and it's those neurons that degenerate in the pathology of Parkinson's disease. Oh. The striatum has other functions as well. And dopamine signaling in the striatum is very important for decision making. We've recently published a report showing that there is a very, very strong relationship between dopamine receptors in the striatum and the function of the prefrontal cortex when a person is deciding to take risk or not take risk. And so what you see with the damage to the dopamine system in the striatum is kind of a situation in which the addict really has a difficult time making the right decision to go to sobriety. It's as if the effects of drug taking reinforce the addiction.
So, given that physiological understanding, is there some research that is being undertaken that can affect the dopamine receptors' ability to recover?
We have some very exciting findings that are preliminary, but strong but preliminary. What we've known is that even though the dopamine receptors show downregulation in methamphetamine dependence, treatments that are aimed directly at the dopamine receptors, agonist drugs that would make the receptors work, don't really work very well for methamphetamine dependence.
Okay.
Maybe that's because the receptors are downregulated so much, or the ones that remain are not functional. And what you really need are fresh dopamine receptors. And using a different approach, we have an ongoing study where exercise, moderate exercise, in a very controlled study has shown a very remarkable upregulation of the dopamine receptors over the course of 8 weeks. This is very exciting, and this might make that system more amenable to all kinds of therapy, be it cognitive behavioral or pharmacological.
Thank you, Dr. London. Would anybody else in the last half minute I have care to weigh in on the dialogue that I've been having with Dr. London? Well, I'm deeply grateful for your testimony here today, your work on this subject. It's enormously important to my state of Wyoming and to that wave of young people now in their 30s and 40s that were tremendously affected. And I would just add that on the Indian reservations in Wyoming and elsewhere, the Mexican drug cartels chose to set up base camps. And between the grinding poverty on reservations and what may be some genetic component to the addiction, they have been tremendously devastating to our Native American population as well. So the work you're doing is just tremendously critical, and I thank you very much. And Mr. Chairman, I thank you and yield back.
Since I missed that you came in during the first round, we have done a second round of questioning. So if you have other questions, I think it'd be appropriate to allow you another 5 minutes for a second line if you have any other questions.
You know, Mr. Chairman, I would just use my time to ask the members of the panel, is there information that you would like to share with us that you haven't been able to convey as yet in your testimony? I want to give you a very open opportunity to make some points that previously have not been made that you don't want to leave this room without making.
I can weigh in first here. I think this is an incredibly complex scenario, and we're not going to find a resolution probably in my lifetime. But I do think what's really, really important is to consider this both on the supply and the demand side, and both in terms of prevention and then adequate treatment. But to understand that treatment may have to do, will have to be highly individualized, because depending on if we catch someone early in their use and exploration of methamphetamine versus someone who's used it for a protracted period of time, that's a different brain state. That's a different individual. If we catch them during early withdrawal periods versus someone like Dr. London was talking about 2.5 years out, when they're even motivated to quit using the drug, and they're fighting against their own brain biology that is influencing their decision-making processes. It's tapping into the brain that actually those brain regions that make decisions that succumb to methamphetamine. So it's a double whammy. And I think we have to have an appreciation for that. And I think that's why this multidisciplinary, highly integrative approach that's going to start young and understand that we've got baby boomers now that are moving into retirement, and they're going to be having drug abuse issues that we're going to have to deal with as a society as well. So I do believe it is going to take a multidisciplinary across institutes, across states, and an education end and a treatment end for us to really make a dent in this problem.
Dr. London?
We haven't said much about the need for an integrated approach in pushing the technology with respect to this problem. And I think we're, especially with respect to the interest of this particular subcommittee, science, technology, and mathematics can really be put into the arena to move the field forward. Particularly, we could talk about the combination of something like nanotechnology with cutting-edge neuroscience methods. That combination could be very powerful with nanotechnology giving you dynamic chemical measurements in very, very discrete areas of the brain. And already there is cutting-edge electrophysiological recording that's being combined in animals with electrochemical detection of glutamate, dopamine, and other neurotransmitters that can give us a moment-to-moment readout of how neurotransmitter signaling can modulate coordinated neural activity. And so I think that we need to keep in mind that we really need better tools, and some of these tools could be within our imaging area. We need to have better radio tracers that will selectively allow us to evaluate chemical changes in the brain.
May I interrupt you there?
Of course.
Where is this research being done now? And with regard to, for example, nanotechnology, radio transmitters, is it being done? Where? And is Congress helping fund that?
There is a California Nanotechnology Institute that's located at UCLA, and I believe it really was an initiative that has been helped by Congress, although I'm not sure of the specifics there. What we also really need are education programs for the specialists. For example, there's a dearth of radiochemists in the world, and it's a specialty that's really required to give us those molecules that would allow us to do these non-invasive measurements.
Where are they trained? Who trains radiochemists?
There is a program at Johns Hopkins. Okay. There's a program at the University of Michigan, the Karolinska Institute, the National Institutes of Health, intramural programs.
Thank you. And I want to thank all of you for your testimony.
I'm going to allow the other two that didn't get a chance to give their final comments some time to follow up with what Ms. Lummis has asked, to just comment on what maybe you might want to say the committee didn't get a chance in your testimony. Start with Sargent Crawford.
At first, when I saw the list of folks that were going to be here to testify, it was kind of one of those situations where I'm really glad I slept at a Holiday Inn Express last night. Because Dr. Sargent. But I will say one of the things that law enforcement, not only within our state but across the country, we're very cognizant that prevention programs are important. And having come from a background within the state police where I worked in our problem-oriented policing section, which focused on community problems and what do we do to help solve those problems, from our aspect. I think it's important that we have, you've heard interdisciplinary all morning this morning, and I think that is such an important thing, that it is so important to get the medical community, the treatment community, the prevention community, and law enforcement together so that we can come in from an interdisciplinary. Because I'm pretty good at coming in to your junior high class, the drug and alcohol or the health class, and I can give them a good one-day program. But if we don't have something leading up to that and we don't have something after that to focus their attention, then I think it's not a waste of an hour, but it's not as productive as it could be. And so from our perspective, while we are big into the enforcement side, obviously, and do our job to enforce the laws that are on the books, we do also focus on, within our section, our mission statement is about education, prevention, and enforcement. And we keep them in that order because we know with education and partnerships and enforcement, with the education and partnerships that we create in the communities that we work, our enforcement efforts are going to be so much better. So the meth watch kits, even though we didn't get the turnaround necessarily from the meth cooks we got great relationships that we built within the communities that offer us very good information about what's going on and where to focus our enforcement efforts. So I think the interdisciplinary is very important.
Dr. Maxwell?
Thank you. In listening to the testimony and in preparing my presentation, I think one of the things that's very, very important is we have a lot of data out there, but it's accessing it and thinking about it. And do things change as we do brain research? What does that mean for the user population or the statistics on what sources? Are they shifting from methamphetamine to something else? It's always looking at little pieces of data, but when I start pulling it together, and I think particularly with the committee's support for going much further in dealing with methamphetamine, we ought to be able to sit down and say, we've made progress here, we're not making progress there. One of the problems that we have now is that after the pseudoephedrine limitations started, everybody declared we'd won the war and gone home, and we don't need any more specialized methamphetamine treatment. They weren't looking at the data. So I'm a data nerd, but I think it tells us often where we need to go and where we've missed the ball.
Well, I'd like to thank all the witnesses again for their testimony. This has been a fascinating hearing, and I think from my perspective, I do think from a research perspective, it is very important that we continue to make sure we have federal support for basic research in all of these areas, as well as other through National Science Foundation, which is under the purview of this subcommittee, and other agencies such as the NIH. I also think it is important probably to have some sort of a national strategy on this type of thing, because in Indiana, if you put laws in place for one thing but the states around you don't, or if the states around you put a law in and you don't, it just gets transferred across the state, especially in Evansville, where we have Illinois, Kentucky, and Indiana right there. So I do think it's appropriate to discuss the national strategy and to attack this particular issue, in my opinion. With that, that ends the hearing, and the hearing's adjourned. Thanks, Dan.